In this chapter, we're going to explore inequalities. Inequalities are similar to equations in that they compare the expression on the left side to the expression on the right side. But rather than comparing whether the left side is equal to the right, it compares whether the left side is greater or less than the right side. Here are some examples. This states that 3 is less than 5. This is a true statement. This states that 11 is greater than 4. This is also true. This states that 3 is less than or equal to 5. 3 is less than 5, so this is also a true statement. This states that 10 is less than or equal to 7. 10 is not less than 7, and 10 is not equal to 7. Thus, this statement is false. Finally, this states that 10 is greater than or equal to 7. 10 is greater than 7, so this statement is true. The symmetric inequality property says that if A is greater than B, then B is less than A. Here are some examples. If 7 is greater than 3, then 3 is less than 7. If x is greater than 10, then 10 is less than x. And if 2 times y plus 5 is greater than 7, then 7 is less than 2 times y plus 5. If a is less than b, then b is greater than a. Here are some examples. If 3 is less than 7, then 7 is greater than 3. If 10 is less than x, then x is greater than 10. If 7 is less than 2 times y plus 5, then 2 times y plus 5 is greater than 7. If a is less than b and b is less than c, then a is less than c. Here are some examples. If 3 is less than 5 and 5 is less than 7, then 3 is less than 7. If x is less than 10 and 10 is less than y, then x is less than y. Finally, if 3 times m is less than 15 plus n, and 15 plus n is less than p plus 3, then 3 times m is less than p plus 3. Let's prove the following theorem. If a is greater than b and b is greater than c, then a is greater than c. We're given that a is greater than b and b is greater than c. Since a is greater than b, we know that b is less than a. And since b is greater than c, we know that c is less than b. Then by the transitive property, we know that c is less than a. Finally, since c is less than a, we know that a is greater than c. The transitive property of inequality says that if a is less than b and b is equal to c, then a is less than c. This is similar to the transitive property of equality, but the first condition and the conclusion are less than operations. Here are some examples. If 5 is less than x and x equals 9, then 5 is less than 9. If x is less than 7 and 7 is equal to y, then x is less than y. If m times n is less than 2 plus f, and 2 plus f equals j times k, then m times n is less than j times k. If a is less than b and a is equal to c, then c is less than b. This is similar to the transitive property of inequality, but instead of substituting b, we're substituting a. Here are some examples. If x is less than y and x is equal to 3, then 3 is less than y. If j plus 4 is less than 7 and j plus 4 equals k, then k is less than 7. If m times n is less than 2 and m times n is equal to j plus k, then j plus k is less than 2. Let's prove the following theorem. If a is greater than b and b is equal to c, then a is greater than c. Since a is greater than b, we know that b is less than a. And if b is less than a and b is equal to c, then c is less than a. Finally, since c is less than a, we know that a is greater than c. Let's prove the following theorem. If a is greater than b and a is equal to c, then c is greater than b. Since a is greater than b, we know that b is less than a. And if b is less than a and a is equal to c, then we know that b is less than c. Finally, since b is less than c, c is greater than b. The inequality addition property says that if a is less than b, then a plus c is less than b plus c. This property allows us to add a value to both sides of the operator. Here are some examples. If 3 is less than 5, then 3 plus 5 is less than 7 plus 5. If x is less than 10, then x plus 8 is less than 10 plus 8. If 3 times m is less than 15 plus n, then 3 times m plus x is less than 15 plus n plus x. If a is less than b and c is greater than 0, then a times c is less than b times c. This property allows us to multiply positive values to both sides of the operator. Here are some examples. If 3 is less than 7, then 3 times 5 is less than 7 times 5. If x is less than 10, then x times 8 is less than 10 times 8. If 3 times m is less than 15 plus n and x is greater than 0, then 3 times m times x is less than 15 plus n times x. If a is less than b and c is less than 0, then a times c is greater than b times c. This property allows us to multiply a value to both sides of the operator, but when the value is negative, we need to flip the operator. Thus, the less than operator becomes the greater than operator, and vice versa. Here's a visual representation of this property. On the right side of the graph, the orange bar extends to 3, while the blue bar extends to 6. We can see that the orange bar is shorter than the blue bar. The left side shows what happens when we multiply by -1. The orange bar extends to -3, while the blue bar extends to -6. Notice that -3 is greater than -6. The orange bar is still shorter, but that means that the orange bar is less negative than the blue bar. Here are some examples. If 3 is less than 5, then 3 times -5 is greater than 7 times -5. If x is less than 10, then x times -8 is greater than 10 times -8. Finally, if 3 times m is less than 15 plus n, then 3 times m times -1 is greater than 15 plus n times -1. If we don't know whether the value is positive or negative, then we do not know whether to flip the operator or not, so we cannot draw a conclusion. If a is greater than 0 and b is greater than 0 and a is less than b, then 1 over a is greater than 1 over b. Here are some examples. If 3 is less than 5, then 1 over 3 is greater than 1 over 5. If x is greater than 0, but x is less than 10, then 1 over x is greater than 1 over 10. Finally, if 3 times m is greater than 0 and 15 plus n is also greater than 0, and 3 times m is less than 15 plus n, then 1 over 3 times m is greater than 1 over 15 plus n. Let's prove that if x plus 4 is greater than 9, then x is greater than 5. The inequality properties allow us to add -4 to both sides. X plus 4 minus 4 equals x, and 9 minus 4 equals 5. So x is greater than 5. Let's prove that if y times 3 is less than 21, then y is less than 7. The inequality properties allow us to divide both sides by 3. Y times 3 divided by 3 equals y, and 21 divided by 3 is 7, so y is less than 7. Let's prove that if y times negative 2 is less than negative 16, then y is greater than 8. The inequality properties allow us to multiply negative 1 over 2 to both sides, but we need to flip the operator to the greater than sign. Y times negative 2 times negative 1 over 2 equals y, and negative 16 times negative 1 over 2 equals 8, so y is greater than 8. Let's prove that if x plus 10 over negative 5 is greater than 3, then x is less than negative 25. For clarity, here's the condition in fraction notation. The inequality properties allow us to multiply negative 5 to both sides, but we need to flip the operator to the less than sign. Then this equation becomes x plus 10 is less than 15. Next, we can add negative 10 to both sides to reach the conclusion. Adding negative 10 does not require us to flip the operator again.